Hi students, very good morning. Now, there are two types of substances, materials, that is conductors and insulators. In the coming sessions we are going to learn more about this, but here just have a basic idea. As you must have from your basic studies you have an idea that conductors means they conduct electricity. Conduct electricity means what? Allows free passage for motion of charge, whereas these do not conduct electricity. Means do not allow the charges to flow through. Now, conducts electricity, do not conduct electricity. So, allows the free passage for the motion of charges. I mean to say, these objects which are called as conductors, they allow the charges to flow through them, and these do not allow the charges to flow through them. Like for example, you think of in daily life you see electricity. For electricity, electrical conduction, we use copper wires, aluminum wires, etc. Right? So copper, aluminum, gold, almost all the metals are good conductors of electricity, we can say. So almost all metals here. Metals are good conductors of electricity. And what about insulators? Of course, you have many again. Like wood is an insulator, so paper or plastic, glass, all these are insulators. So all these are insulators. That is, they do not conduct electricity. Like you see that in electrical conducting wires. So what we use cables and all. Like for a conduction of electricity, there we see the outer coating is plastic, whereas inside there is a copper string. So that copper string or aluminum string inside, that carries the charges from one place to another, means it conducts electricity. Whereas to avoid getting shock, we just cover it with a insulator there. That is plastic coating. Anyways, so that is about conductors and insulators. So keep this in mind, and let's just move to now the important characteristics of charges. Characteristics of charges. So, number one, charge is conserved. This is a very important characteristic of charge. Charge is conserved. Of course, you know, mass conservation you have learned earlier, energy conservation you have learned, right? So, mass and energy, of course, interconvertible, but energy is conserved, we say. So, energy can neither be created nor be destroyed. Same thing here, that is, charge can neither be created nor be destroyed. Charge can neither be created nor be destroyed. Or you can say the total charge in an isolated system always remains a constant. An isolated system means you just think of a container, an enclosure, which has some charges, say some bodies are there, objects are there here in this maybe. So this has say 4 coulombs of charge, this is 5 coulombs of charge, this is 2 coulombs of charge, and there is a body in this here, 1 coulomb of charge, etc. Now you may do something with this, you may just check the system or whatever you do, you transfer charges from one body to another and etc. So after some time you may find this body has 6 coulombs, this body has 3 coulombs, this body has 3 coulombs, this body has 0, no charge, something like that. So but then 4 plus 5, 9, 10, 11, 12, 12 coulombs here. Now 6 plus 3, 9, 10, 11, 12, 12 coulombs here also. So whatever you do with the system, as far as it is isolated, as far as there is no transfer of charge from this system to external or from external to this, then the total charge in this system remains constant. That is called the charge is conserved. It can neither be created nor be destroyed. Then, secondly, charge is quantized. So, charge is conserved. Understood? This is quantized. The second important characteristic. What is the meaning of quantized? Quantized means takes discrete values. Discrete values are fixed quanta. I mean fixed quantities. It will just jump into fixed quantities here. I mean to say, like for example, say there is one electron charge, which is the minimum possible charge. Okay, so that is 1.6 into 10 to the power minus 19 coulomb. What is the next possibility? What is the next bigger charge possible? 2 times the electron. That's all. There is nothing like 1.5 times electron charge. Impossible. Therefore, this takes charge takes values as E, that is electron charge, I can say, then 2E, 3E, etc. Means it is going to take values as NE, as integral multiple of electron charge. Means Q is equal to NE, right? Where N is an integer. So Q takes only discrete values, that is 1 time electron charge, or 2 times electron charge, 3 times electron charge, etc. Now, in case if somebody asks you, is it possible to have some particular amount of charge, say 10 coulombs of charge? Is it possible to have 10 coulombs of charge? You just divide this 10 coulombs by 1 electron charge. If you get an integer, then it means to say it is possible. Now, if somebody asks you, say, is it possible to have, I will write it here, is it possible to have Q is equal to 1.5 into 10 to the power minus 19 coulomb? Is it possible to have this charge? Now just try. You divide this by how much do you get? 1.5 by 1.6 is less than 1, right? So, of course, here 10 to the minus 19 cancels. This is less than 1. So, it is understood that it is not an integer. Therefore, it is not possible to have this charge. Whereas, if somebody asks you, is it possible to have 3.2 into 10 to the power minus 19 coulombs of charge? You divide this by 1.6 into 10 to the power minus 19. So, you find that it is 2. So, 2 is integer. Yes, it is possible to have. So, it is possible to have only integral multiple of electron charge. So, thus it is said to be quantized. So, charge is quantized. Charge is additive in nature. Charge is additive. It follows a simple basic principle of addition. I mean, if you have 3 coulombs of charge plus 2 coulombs of charge is 5 coulombs of charge. Very simple. So, whereas if you take 5 coulombs of charge and 2 coulombs of charge negative, then total will be 3 coulombs of charge. So, charge follows the basic principles of addition. So, it is a scalar quantity. It is not a vector quantity. You know, vectors, if it is a vector, then it has to follow the vector law of addition, right? It has no direction. It is just a scalar quantity. Simple addition works out here. So, of course, you can take this itself as another characteristic if you want. It is a scalar quantity. It doesn't have direction. So, these are the important characteristics of charges. So, shall we remove this? Now, let us try and understand how to add charges to a body. That is, methods of charging or electrification. Methods of charging or methods of electrification. So, adding charges to a body is called as electrification. Now, let us just check how to do that. See, in your schooling time, you have seen when you just pass a rubber comb through your dry hair and take it close to the paper bits, small bits of paper, you see that the paper bits are attracted to the comb. What is that due to? It is due to the concept called charging. Now, there are similar such many phenomena which in daily life you come across where charging happens and discharging effect is observed. The discharging causes a mild electric shock sometimes, like you just get off from a seat while moving a bus, while sitting on a bus seat, you just get off from the seat and touch an iron rod or something. You find that mild shock you get. That is due to discharging effect during, of course, after charging. Now, how does that charging happens and then discharging happens? So, let us just go in a bit deep depth here. So, let us start with different methods of charging. Number one here, by friction. Charging by friction. So, this happens between insulators. If you take two insulating bodies, two objects which are insulators, and rub them against each other, there will be friction, and that friction causes charging. So, how does that happen? Let us look into that. You just consider an object, and say that is an insulator, and this is another object which is also an insulator. Now, any object you take, it has sharp, ups and downs on its surface. You know that. Now, when you just rub these two objects together, what is happening? There is friction. You are providing kinetic energy, and that kinetic energy is converted into thermal energy, and that thermal energy will increase the energy of electrons which are in the outermost orbits on the surface here in the atoms. Okay, this object has some atoms, and in those atoms, the outermost orbits, electrons, they are vulnerable. I mean to say, once they get the ionization energy, the electrons come out of the atoms, right? You know the process of ionization. Now, here the same thing happens. You gave some thermal energy to the system by rubbing. Friction causes thermal energy, and when that thermal energy is sufficient to remove the electron, ionize the atoms there, then electrons jump from one object to another here, right? So now, electrons may be kicked out, right? So thereby you find that the two objects here become charged. Something like this. When you rub these two objects, say for example, this object gains energy which is sufficient to remove the electrons from here, then those electrons jump to the other object. The object which loses electrons becomes positive. So electrons jump like this, say, okay? So when electrons jump like that, the object which loses electrons becomes positive, and the one which gains electrons becomes negative. So this is negatively charged, this is positively charged. Now these two objects are said to be charged, and this is charging by friction. That is what happens when you just pass a rubber comb through your dry hair. There is friction between the comb and the hairs. So that friction causes charging of the comb as well as your hair, of course. That charged comb attracts the paper bits. Now you may be thinking now, why does a charged comb attract paper bits? Of course, that is another method of charging we are going to see later. Now, second is charging by conduction. Conduction, of course, this happens with conductors. You consider an object, a conductor you just consider, which is already charged. It has, say, some negative charges. You take another conductor which is neutral, initially neutral, and bring it in contact with the first conductor. This is readily charged. This is already charged. How did you charge this? Of course, there are different methods. You know that there is friction is one of the methods. Maybe by friction method or some method you got a charge on this body. Okay, that you will understand later how to charge a body. After you understand another method, everything will be clear to you. For now, you just imagine there is one charged body here, which is a conductor basically. And now bring another conductor in contact with this first conductor. You see that because as the name itself says is a conductor, it allows the charges to flow through. Then all these negatives, they are repelling each other, right? So some of the negatives will transfer to the second object. Means you find that some of the charges came onto the second object. Thereby you find the two charge bodies. So 3, 3, 6, 7, maybe something like this. Some of the charges moved to the second object. Now both of them are charged because they shared the charges. Once they came into contact, the charges from one object moved on to the other because both of them conduct, and thereby both of them are charged. Now if you separate them and keep, both are charged bodies, we can say. And one more thing you just remember here, if these two bodies are identical, I mean to say, if first body is already charged, that is maybe it's a spherical conductor, okay, if you take a second object of the same material, same shape, same size, everything same material, same characteristics. So if both these bodies are identical, except that this is charged, this is not charged, then when you bring them in contact, charges from one will move to the other in such a way that at the end, after the process of transfer of charge is complete, both of them will have equal amount of charge, exactly same amount of charge will be there on either of them, just because they both are identical. So this is charging by conduction. Now similarly you have, I'll remove this. Then third method, charging by induction. And remember here, charging by conduction means this is direct contact. Direct contact. You are bringing a second object in contact with the first object, then only they are getting charged. I mean, the second object is getting charged. Whereas here, induced, induction, the charges are induced. Means there is no contact here. No contact. Without bringing any object in contact, we are charging it. So how do we do that? So once again, let me just take a charged body. Say it has some negative charges. Okay, it's already charged body. And of course, remember that when I say any object you take, maybe this duster, is it charged? No, let us say it is neutral now. Okay, if this is neutral, if this object is neutral, it has electrons or not? Yes, it has. It has equal number of electrons and protons. Then only it is neutral. Because you know, any object is made up of what? Atoms and molecules, right? Atoms will be there now inside. And each atom is having what? A central part called as nucleus, which has protons and neutrons. And in the outer orbits, there are electrons around the nucleus. And how many electrons will be there? Equal number in comparison to the protons. Thereby, every atom is neutral. Like. So, the whole system is neutral, but this system has both positive and negative charges, that is protons and electrons, but the sum effect is zero. That is, positive charges nullify the effect of the negative charges, that's all. So that is why it is called as a neutral object. And it is not charged, we can say. It is not charged. It doesn't mean that it doesn't have charges in it. So charges are there, but it is not charged. I mean to say, its effect is neutral. It is neutral object now. Equal number of protons and electrons are there. Now in case, if I add some electrons to it, then it will become negatively charged. Simple. Okay, now forget about adding. Now it is a neutral object. Now, if I take out some electrons from it, then you know there is a shortage of electrons. So it is a positive ion, a positively charged body, you can say, correct? So from an atom, if you just remove an electron, it will become positive ion, you know that. So same way, from this object, when I remove some electrons, the total number of protons in the system is more compared to the total number of electrons existing now, and thereby you can say positive effect is more, negative effect is less. So effectively, it is positively charged, we can say. Now remember that when you say a body is charged to negative, it means it has excess electrons compared to protons, and when you say a body has positive charge, then it means to say it is short of electrons compared to protons, means proton number is more compared to electrons. It doesn't mean that you have added protons, no. we have either added electrons or removed electrons to make the body either negatively charged or positively charged respectively. Now coming to charging by induction. Now just think of an object which is already charged, say negative charge is there. Now you bring another object close to it, just yeah. So I'll just bring an object close to the first object. This is neutral. Neutral means it has equal number of positive and negative charges. I mean negative electrons and protons. Equal number of electrons and protons are there, therefore it is neutral. Now once you bring this charged body close to this second neutral body, then the electrons from it, which electrons and protons both are there, right? So electrons in it, they are getting repelled by this charge because you brought this charge close to the second object. So these negative charges will repel the negative charges in this. So you find that electrons will move to the other end, and this end effectively becomes positively charged, right? So one end is positive now, effectively the other end is negative. Now what did we do here? By just bringing a charged body close to a neutral conductor, we just separated the positive and negative charges here. Positive charges move to one end, negative charges move to the other end. Now in case if I remove these negative charges, then this system will have only positive charges, correct? It is positively charged then. So how do I remove these negative charges here? Very easy. Just connect a wire to the earth. There is earthing or grounding, what you call. So when you make a connection of this object with the earth is earth is having too many electrons and protons, so it's abundant of electrons. It is a sea of electrons there. So if you want electrons, it will give. If you give electrons, it will take. But nothing affects the earth here. If you take electrons or give electrons, earth will not be charged at all. It remains neutral only. So that is why it is grounding because. So this process is grounding because. So once I make this connection, these excess electrons will move to the earth. All these excess electrons will move to the earth, and thereby this part becomes neutral. So once that happens, then you disconnect this, and the object here, let me just remove this. So the object here having positive charges, right? Those positive charges will not sit at the corner. Now, if I just take this away, these positive charges will distribute uniformly. I mean, I remove this earth connection now. Once I remove this earth connection, let me take a diagram here. These electrons are gone to the earth. Now what is remaining? Only positive charge. And I remove this object also now. After doing all that, the positive charges which were supposed to be at this end in this manner, they repel each other and they distribute themselves uniformly on the surface of the conductor. Now this object is charged. It's a charged conductor now, right? So earth connection neutralizes the negative charges, remaining only positive charges left out. Thereby the body is positively charged. Now you can understand, in case if I want to charge this body to negative, then what should I do? Just bring a positively charged body here. Bring a positively charged body, then all negative charges get attracted and positives are repelled. Then when earth connection is made, earth will provide some electrons to neutralize the effect of positive, and thereby only negatives will be left out, and they distribute themselves uniformly to make the body negatively charged. So this is charging by induction. Now this is what happens when you just bring the charged comb towards the paper bits. I mean to say, when you just pass the rubber comb through your dry hair, there is a friction between the comb and the hair, and that causes the comb to be charged. That is charging by friction. When that charged comb is brought close to the paper bits, small pieces of paper, then you find that once the charged body comes close to the small paper bits, just like this, you find in the paper piece, the opposite kind of charges, they get attracted, and there is a attraction between the comb and the end of paper bits which are closer, and thereby paper bits fly off and stick to the comb. This is charging by induction there. Now there is charging by friction and induction both in that small experiment. Thank you very much.